Now, where it gets interesting is when you apply it to arrays. Okay, this is a really powerful analysis technique for data. But you can, let's say we have an array A here. We can ask, is A greater than 3? And what that will do, it'll apply that condition to every element of the array and give me an array of ones and zeros. It's called a logical array. Okay, so I can look at that and I can say the first and last elements of this array meet this condition. They're greater than 3. The rest of them do not. And you can do the same thing by comparing two arrays, as long as they have the same number of elements, the same dimensions. Okay, what it will do, it'll compare them element by element. So is 5 less than 11? Is 4 less than 4? Is 3 less than 1? And so forth. Okay, and again, I get a logical array of results. Okay, so 5 is less than 11, so I got a 1, but 4 is not less than 4, so I got a 0. Now, so a little bit ago, I showed you this technique where you can combine relational operations with arithmetic. You can do the same thing with arrays. And it's a really powerful technique once you become skilled at it, but it's a little tricky to use. But let's say we wanted to make a vector f that's equal to the corresponding element of C if C is greater than D. Okay, so we're comparing these two arrays that we had here. And for the cases where C is greater than D, we want to keep that value. We want to keep the value of C. Otherwise, we want a minus 1. So here's one way to do that. Okay, so you do a relational operation, C greater than D. That gives you a logical array, ones and zeros. If you then dot that, dot multiply it with C, it picks out the elements of C every place where this condition is true. Okay, so when I do C greater than D, I get 0, 0, 1, 0, 0. So when I dot C with that, it only picks out the third one. It's the only place where there's a 1, so I get only a 3. Everything else is zeros. And then I put the complementary condition here, C less than or equal to D. Okay, so every place where the first one was 1, the second term will be 0 and vice versa. All right. And what do I want it to be in that case? I want it to be minus 1. So I just multiply by minus 1. And then I add the two together. And this is what I end up with. But it's interesting to see that this one line does the same thing that this whole block of code did. Okay, so this is the way you were taught to do it in 1181. You do a loop, you look at each element of the array, you do an if statement to compare them. If C is greater than D, then you set F to be C. Otherwise, you set F to be minus 1, and you have to use the indexing because you're doing it one element at a time. You can do all of this with this one line. And this is a better way of doing it. It's more efficient computationally. And so if you have a huge array, this will take less time. And it's just more compact as well. All right. So that's why we cover this technique before we go back to doing loops and if statements, because we want you to get comfortable with this first. Because whenever you can do it this way, it's actually better to do it this way instead of resorting to a loop. All right, let's try one. Let's take 2 minutes. So we have an array X, and we want to do an expression similar to this, where if X is between minus 5 and 5, so if it's greater than or equal to minus 5 and less than or equal to plus 5, then we want it to be 0. If it's less than minus 5, we want it to be minus 1. And if it's greater than 5, we want it to be plus 1.